Hey, John Crooks here with part 4 in our series of presentations on pitch and pitch systems in tonal music. Today we will take the 4:5:6 ratio, also called the triad, and learn a little bit more about it in context of the circle of fifths. Both of these are topics we covered in the previous presentation, number 3. And what we're going to be doing is understanding what the 1, 4, and 5 chord functions are in terms of just mathematics and ratios and how we can see these in the circle of fifths. This 1 to 4 to 5 chord progression can also be called tonic, subdominant, and dominant, and it's a very big part of tonal harmony. As I've mentioned in another presentation, we're not going to go very deep into tonal harmony in this series. What we're doing is trying to understand what the mathematics are of the tonal system, and hopefully this will illuminate a little bit about what music is and how we hear it. So right now what we'll go over to do is a presentation about how triads work in the context of the circle of fifths. So now we'll learn a bit more about the triad and circular pitch systems. As we discussed in an earlier presentation, the circle of fifths uses a circle to represent octave equivalents, and this circle of fifths also functions as a kind of shorthand description of how our ear parses tonal pitch systems. On the circle, each adjacent pair of points represents a 3:2 or perfect fifth frequency ratio. This shows a hierarchy in tonal musical ratios. 2:1, the octave, represented by the entire circle, is primary. The 3:2 fifth is secondary. It's easy to take this diagram for granted, but it really is a great way for us to understand how we hear and organize pitch in tonal pitch spaces. Of course, there are several more intervals, and they're important too. But right now, we're going to focus on this octave, the perfect fifth, and also the major third that we just learned about. This 5:4 major third can be placed within a 3:2 ratio to form a 4:5:6 ratio major triad. Tonal harmony uses these triads to reinforce the 3:2 ratio and other frequency ratios we are familiar with. In other words, we use triads to extend the ratios that we hear in the octave and the fifth. We make them even more well reinforced when we add major thirds. So take this C, for example. When we add E and G, we get a 4:5:6 triad, and our brain makes C the most important tonic pitch in that collection of 3 pitches. And this idea of tonicization is key to the understanding of tonal music. If we go around the circle of fifths clockwise, we get to the 3:2 fifth. And if we hear this fifth sounded, we hear a related sound that can lead the ear back to C. Further, if we put another triad on G, one that's spelled G, B, D, that sense of C-ness or C tonality is reinforced even more. This is called the dominant chord or 5 chord. Something similar happens when we play the triad based on the 2:3 ratio below C or F. This is called the dominant or 4 triad. And if we hear these triads in order, 4, 5, 1, we'll hear something very familiar, which is both a common cell phone ring and also a real shorthand, 4, 5, 1, for how our tonal system works. And these are called the tonic, subdominant 4, and dominant 5 chords. This tonic, dominant, subdominant pattern follows all around our circle of 3:2 ratios that we call the circle of fifths. The triads based on pitches directly beside a tonic triad reinforce the tonic sound. So here we can hear it with the tonic now being G. The 4 chord is C, and the 5 chord is D. Because the ratios are the same, the progression sounds about the same, but its effect is to reinforce the pitch G now instead of C. And let's just take a minute and see how this works around our circle of fifths. Now we're in F, so it'll be a 4 chord that is B flat, 5 is C, and 1 is F. Now in D, we'll have G, A, D. E flat, F, and B. Notice how it is the pitches adjacent to a central pitch that form the subdominant and dominant chords. D, E, A. A flat, B flat, and E flat. A, B, E. D flat, E flat, and A flat. E, F sharp, and B. F sharp, G sharp, and C sharp. And now finally we've completed our circle when we hear a B major triad, a C sharp major triad, tonicizing the F sharp 1 triad. So this circle of fifths is a diagram that uses 2:1 and 3:2 ratios in its structure. In tonal harmony, these are expanded with tonic, dominant, and subdominant 4-5 to 6 triad relationships. And this really is the crux of the tonal system. We have these perfect fifths that sound very good and strong. We expand them with a major third, and we suddenly create a system where related triads, ones that are related by this perfect fifth or perfect fourth relationship, such as C to G, which is a perfect fifth, or C to F, which is a perfect fourth, also have this tonic subdominant-dominant relationship. It would make sense then that the pitch system used for pianos, guitars, and any instrument with fixed pitch should use perfectly tuned 3-2 fifths, 5-4 major thirds, and 2-1 octaves, so that all of the triads would have that nice 4-5 to 6 rational relationship. But the tuning system in common use today for pianos and organs and electronic keyboards, etc., does not have any pure intervals or just intervals other than the 2-1 octave. Why is this? Well, as we go through our series of presentations, we will find out. And that is the mystery we're trying to get to the bottom of in this series of presentations. It's interesting to understand how simple ratios really govern the tonal system, things like octaves and fifths and fourths and thirds. But when we look at our tuning system for tonal music, the way pianos and guitars are tuned, the way our electronic keyboards are laid out, we hear frequencies that are in ratios that are much more complex. And there is a reason why, but in order to get to that reason, we have to work through some of the basic mathematics, which we will start doing in our next episode, where I'm excited to say we will build a major scale using simple math. So thanks for tuning in to this presentation, and please stay tuned for the next.